Hi, everyone. We're just waiting for everyone else to join. So there should be a few of us joining tonight. So we'll just monitor those numbers till they come here. But thanks for joining us so far.
It looks like we're about halfway so far.
I'll have to remember some jokes for next time. I'll get those lined up. I'll give another couple minutes.
Yeah, and while everyone's waiting, I can go over a few house call items for the evening. We have disabled the chat function. So if you do have any questions, please use the Q&A for any questions that come out throughout the presentation. We will do our best to answer them at the end after Ian's done his presentation tonight for us. If there's a question that you see that you can also relate to, please click on it. It'll be something will pop up that says upvote for you. So if there's a question that has a few more upvotes, we'll make sure we do a good job of answering those questions first. I think we'll give it one more minute here before we get started. And thank you everyone for taking your time away to join us and join Ian on his presentation for us this evening. I'm really looking forward to it. And I hope that everyone has some great information that they can take away from this as well.
Good. Well, if you don't mind, I'll get started. Other people can join as they keep coming in. So they'll have lots of opportunity to answer questions later on. Yeah, thanks again for joining us tonight. I'm excited to talk to you about this stuff. You can probably see that as I go through this, I get pretty animated about that. So excuse me if my hands start flying off the screen as I'm talking about something really big. To me, this is some of the coolest stuff that I love working on day in, day out. And I hope that I can kind of show you why I think it's so important and also some of the opportunities you have to reduce your greenhouse gas emissions and also to save a lot of money along the way. And also little choices you can make to have a big effect on the environment too. To give you a bit of background on me, thank you for the introduction again. Yeah, my name is Ian Welle and I work for Polar Engineering. I have a background in mechanical engineering and a specialization in advanced thermodynamics. I have worked kind of all over this industry around the world, but I was the lead mechanical engineer for Accent Refrigeration for 6 or 7 years. And recently have joined Polar Engineering to start working on the consulting side and have been lucky enough to partner with companies like Fraser Valley, Yeti Refrigeration, and Accent to design these sorts of systems, design ammonia and freon systems for curling clubs, arenas, and I've been actually focusing on a lot of telescope stuff recently too, doing a lot of CO2 jobs, but I'm not going to talk about that today. Anyway, so today, this presentation should take about half an hour and then we'll have questions at the end. So feel free to ask questions and I'll be around for as long as you have questions. So this presentation we've broken up into two main parts. One, the first one which would be, why should I, being you, care about refrigerants? I think this is a question that a lot of people ask me, but I'm hoping I can hit that home for you to make you realize why refrigerants are so important and why they're worth talking about. And to kind of spoil the story a little bit, it's because they're the single biggest contributor to global warming on the planet. And I'll dig into that later because that's a huge statement. And then also because of this, what regulations are coming your way from the Canadian government. And then looking at part two would be shifting into cost savings and greenhouse gas reductions. And then finally looking at a case study, because I think it's really important to see, do these systems actually work? It's great to talk about them, but we don't want to build systems that cost a bunch of money and then don't work and don't actually realize the energy savings. So I think it's really great to look at where they've worked and what has worked and what hasn't worked. One thing I want to talk about too is I realize due to these tight economic times for a lot of facilities that people are looking at expanding their facilities or talking about these types of projects. And because of that, I wanted to offer a 20% reduction to anyone that's a member of Curl BC in the next 2 months if they want to work with me. So if you want to reach out to me after this or something you're interested in, I'd be really excited to talk to you about it. But shifting away from that. So I don't know if any of you have heard of this book. It's called Project Drawdown. I think it's fascinating. Basically what they did is they looked at the entire globe, and then they looked at the globe and analyzed it from lots of different angles to look at what were the contributors, what was contributing to global warming around the planet. And from this analysis, they were able to figure out that actually refrigerants were the single largest contributor to global warming around the planet. And you might ask, why can that be? And I'll explain that in a little more detail, but this graph kind of hits it home for me. So if you look at the top there, that big purple slice up at the top, that's all due to refrigeration. So if we look at refrigerants have a larger contribution to global warming than if we invested in things like wind turbines, or if we looked at aggressively pursuing tropical rainforest deforestation. And refrigerants in general contribute around 11 to 15% of global warming around the planet. So this is the single biggest thing that we can do to make a difference around the globe. It's bigger than nuclear, tropical forests, wind turbines, which are all these things that we talk about. Solar, for example, bigger than that. Things we talk about all the time that are having a huge effect on global warming. But the thing that we're using day in, day out to provide cooling to our curling clubs is actually one of the biggest culprits. And so why is this though? This is a quick analysis that I put together to look at different types of refrigerants. And so basically the culprit isn't actually doing heat recovery in your refrigeration systems. What it is it's actually the chemicals that are inside your refrigeration systems. And ammonia is, it is toxic, yes, but it actually has zero effect on the environment. So that's why a lot of people really like ammonia, is that it's the most energy efficient refrigerant and it's great for the environment as it has no negative effects on the environment. But then the question has been, when we have often used things such that the industry kind of calls in general freons, when they're released into the environment, they have a huge negative effect on the environment. So to put it in perspective, if you had a curling club full of R404A, and by I mean a curling club full, I mean just your refrigeration system in a curling club is probably around 200, maybe 300 pounds of refrigerants. If that gas escapes from your refrigeration system and is released into the atmosphere, it's equivalent to releasing 500 tons of CO2 into the atmosphere. And to put that into perspective again, that's sort of the equivalent of around 10 curling clubs of the entire natural gas emissions that you produce in a year is probably around the 50-ton mark. So it's around maybe 8, maybe 9 curling clubs worth of fossil fuel emissions for the entire year. Just happens when you release that refrigerant into the atmosphere. And then if you look at another refrigerant, R134A, which is very commonly used in, say, refrigeration systems that would come off the shelf from like Train or Carrier or those types of systems, if you release basically 2 curling clubs worth of refrigerant into the atmosphere, it's equivalent to releasing 500 tons of CO2 into the atmosphere. So it changes based on which type of refrigerant you use, but they all have a very large effect on the atmosphere. So if we look at that, what can we do about that as a world? So the world saw this problem. They said, great, refrigerants are the single largest contributor to global warming on the planet. What can we do about that? So in 2016, 91 countries signed the Kigali Agreement. And that was a whole slew of green energy metrics and talk about trying to reduce our fossil fuel emissions, things like that. But one of the biggest things they actually did was start to regulate the types of refrigerants that we could use in our system. So whether we use R507 or R44A or CO2 or ammonia, they're trying to help us pick the right refrigerant so that in 5-10 years from now, we don't have to change out the type of refrigerant we use. So what does that mean though for Canada? Because that's what affects you and me every day. So in Canada, we said that any refrigerant which has a global warming potential, also known as GWP, greater than 700, means that we will not be able to import that or produce it inside of Canada. And so what that means for you is that if you're installing a refrigeration system today, it's really important to ask the contractor who's performing that work that what refrigerant is going into the system and does it meet the new regulations. I don't expect you to remember all the facts and figures that I've been giving to you, but just to have that in the back of your mind that it's really important what refrigerant you pick, because after the year 2025, you will not be able to either import that or purchase that. So if you lose your refrigerant charge, the cost is going to go up like crazy to replace those systems. And then it will cost you an arm and a leg to get your refrigeration system back up and running. So that's one of the reasons why it's really important to look at purchasing refrigeration systems or refrigerants which are what's called future-proof, which are picking low global warming potential refrigerants for two reasons. One, because it's the right thing to do for the environment, because if you pick the wrong refrigerant, it could have a huge effect on the environment when those chemicals accidentally get released. And around the globe, around 10% of refrigerants are released per annum or per year. And then also that it's going to cost you a lot of money if and when those refrigerants get released into the atmosphere. There has been a lot of solutions for this because, of course, when the industry needs a new product, the industry answers. So when curling clubs say we need a new refrigerant that will be able to replace, for example, R134A, we can use new refrigerants. And so to replace R134A, for example, there's new refrigerants called R513, which is a great refrigerant, works really well, and it can be placed into an R134A system without fairly minimal upgrades, which is nice. But it's important to ask the question today is, what refrigerant am I buying today to make sure that I'll be able to continue to buy it in years to come? Because our facilities are around for a long time and we want to keep curling for years and years and years to come. And it's really important to make sure that we're asking those questions today that don't add a large cost today, but make sure that we're saving a lot of money 5-10 years from now. So that's part one, and I covered a lot of information there, but the big thing to take away from all that is that what refrigerant you choose has never been more important. And so it's important to ask any one of your contractors or engineers when you're installing it, are they picking refrigerants that'll be around in 5-10 years, or are they picking refrigerants that are great today but won't be great tomorrow? The next thing I want to look at is something that's near and dear to my heart, is what can you do to do plant electric reduction? So if you're looking at how much money you're paying right now to run your refrigeration system, it can be a fairly large portion of a facility's budget. And so what are really simple, cost-effective ways to look at reducing the amount of electricity used? And the easiest thing to do, there's kind of two main ideas when you look at heat recovery. The first one is reducing the amount of electricity you use, and the other one is to reduce the amount of fossil fuels you use through heat recovery. And heat recovery has been the one system that's been talked about over and over and over again in the last couple of years. And I'll address a couple new ideas, what we've thought about in the last 2 to 3 years about new types of systems that have made that much more cost effective. But first, I'm going to look at reducing the amount of power you use in your system. Because if you're looking for low hanging fruit or bang for your buck, these are the best things to do. So all of these numbers have been updated for a 8-sheet curling club. If you had a 4-sheet curling club, for example, your cost savings would probably be about 60% of what you would see on my screen. But the first thing you want to look at is your condenser. And these are the main two things you can do. By putting a VFD, which stands for variable frequency device, by putting this component on there, all it does is it slows down the speed at which the which the motors are turning, and that drastically reduces the amount of power we're using. So the first thing you can do is look at putting a VFD in your system. And I should clarify that luckily BC Hydro through the Power Smart program has offered 50% of the construction costs, or around 50% of the construction costs, to install VFDs in your facilities. And that's a fairly cost-effective solution. The average VFD should maybe be $6,000 or $7,000 to install in your systems, and so they will pay around $3,000 to $3,500 of that cost for you to make it much more cost-effective. So that's an important to be aware of, that someone will help you foot the bill, and it becomes almost a no-brainer in terms of investment into your future. So I just want to do a little comparison of what it looks like. So the first thing we wanted to look at was putting a VFD on your condenser, which is the items on the top of my screen there where the red line or the red arrow is pointing into. And basically, if the Victoria Curling Club's on this line, I have to admit that I plagiarized some photos from you, so I hope you forgive me. But so you'll see the inside there. So if I looked at the Victoria Curling Club and I need to provide great ice for all the people working in the facilities, that is a given, that must happen. But if I can reduce the amount of electricity it costs to do that, then that's the easiest thing to do. And what I can do is I can put a VFD on my condenser that allows me to decrease the compression ratio across my compressor. And that's the main workhorse across that. So what I could do is I can decrease my discharge pressure, for DP I put for short, from 150 PSI to 100 PSI. And that makes it basically the compressor doesn't have to work as hard. And kind of a way to imagine this is to think about a bike pump. We've all spent some time pumping up and down our bikes and making sure that our tires are inflated to go for that nice bike ride on a day like today. And what we want to do is, if you think about it, it actually gets way harder to pump with the bike pump when our tires are almost up to pressure. And we've all had that, where we had to push harder and harder and harder to get the same amount of air into our tires. And it's the exact same thing with the compressor. So if I'm changing my compression ratio, or the amount what we call lift in the industry of the compressors, if I can decrease that by putting a VFD on my condenser and modulating the discharge pressure, then I'll be able to provide the same great conditions inside my facility, but reduce my operating costs fairly drastically. So again, these costs have all been based on an 8-sheet curling club, but I should be able to reduce my costs from around $20,000 or $19,000 all the way down to $14,000 of a cost saving of around $5,000 a year, which is huge for doing no difference. I'm not operating my facility any differently. I'm providing the same ice. I'm at the same runtime. All I've done is optimize how my system has performed to reduce the amount of energy or electricity that I have to buy to operate my system. So that's very similar to, say, installing a heat pump at your house versus a baseboard heater. It's the same kind of idea. I'm producing the same end product, but I'm doing it for a lot more cost-effective way. And the payback periods on systems like this are in the realm of around 2 to 3 years at most. The next thing to do is to think about your brine pump. So this pump here is sending brine usually every 4 inches. There's a pipe going underneath your curling club. I don't know if you can see my mouse here underneath this this curling club. And there's pipes going in. And through this uses a brine pump to push fluid. And if I can slow the speed of that pump down, I can reduce the cost of running that pump by around $1,500 a year, just by reducing the speed. And what I would do is I'd run that pump at 100% when I was making ice. And then when I didn't need to make ice anymore, I'd run it at 80% to maintain a great curling surface, have a really even temperature across my entire floor. That's, as we all know, that's super important. And in doing that, I would save an easy $1,500 a year for a very minimal cost. So if we're looking at this, just looking at this from a business perspective, because I think it's really important that we're great, Ian, we want to do all these energy recovery projects, but does it actually make sense for money? So if I say it costs $6,000 to install one of these VFDs on the system, on the brine pump, for example, And then the government pays for half of that. It cost me $3,000. So I could take that $3,000 here on the blue line and invest it in the stock market, or I could invest it in a VFD for my brine pump. So I'm at negative $3,000 here, or I have positive $3,000. And if I look at what happens over 15 years from year 0 to year 14, which is equivalent to 15 years, at the end of 15 years, I have saved $18,000 from putting that money in a brine pump, or I have double the amount of money, which is great. So that's a good investment of over $6,700. But if you look at this is actually a great investment. It would over double your investment in terms of putting it in the stock market and just letting it sit there with I assumed a 7% return on investment per year. But this is the kind of thing to make you think about that it's actually a good use of your money for your facility. If you have the extra $3,000 to install a system or $3,500 to install a system like this, it could be very cost advantageous for you. And if you're not sure what kind of systems you need, I would be happy to help you look at that. It'd be very inexpensive to look at that to figure out what exactly you need for your facility. The next thing that everyone talks about all the time is doing heat recovery. So you're cooling your curling club and then you're getting rid of all that energy through your condenser. That's what your refrigeration system is designed to do. So at the Victoria Curling Club, for example, they're cooling their whole slab right here, and then they're taking that energy and they're sending it outside. But what you could do, a lot of you have dehumidifiers providing great surfaces to stop all condensation from forming in your facilities. And those dehumidifiers often burn natural gas to pull moisture out of your curling club. And so I did a quick analysis yesterday, and if you installed a high temperature heat pump, you could reduce your fossil fuel emissions by, remember I said about 50, 60 tons, it would be around 56 tons of CO2 a year. So if we want to look at that on a high level, that's the equivalent to planting 2,240 trees per year. Every year, planting that for the entire time your refrigeration system is running. It's also the equivalent of around 10 to 12 people. They're equivalent to the amount of CO2 that they produce in a year. And you can look at reducing that. Heat recovery systems don't have payback periods of like VFDs. VFDs are probably around 2 to 3 years. Energy recovery systems are around 9 years. And the high temperature heat pumps, I'm going to skip up to the other to this top slide. The high temperature heat pumps that I have designed over the last couple of years, what they do is they allow you to integrate directly into the Munters unit or into your hot water for your facility. So due to the fact that curling clubs don't use that much hot water, though, in comparison to a lot of other facilities like arenas, this becomes the best place, the best bang for your buck to put that heat into. And they have payback periods of around 9 years. The good news is that Clean BC thinks it's really important to reduce our fossil fuel emissions as a province. And so they will provide 50% of the engineering and 50% of the construction costs, up to 50%, I should say, of the construction costs. And currently I'm working with West Shore Parks and Rec, the CRD in Victoria, and also Mackenzie, the city of Mackenzie, to install systems leveraging these grants to install high temperature heat recovery systems for them. So it becomes a pretty good investment for you as well on that, when a large portion of your capital outlay would be covered both by the by Clean BC or by the government. 50% of the engineering is for an engineering study required by the government to make sure that they're investing their money in projects that make sense. So there's an engineering study that's done, and you have to be approved with Clean BC, and I'm one of the engineers that's approved to do analysis of curling clubs and arenas across BC. So stepping back, does this technology actually work though? Because we've all heard of the projects where people have spent a lot of hard-earned money and installed systems and not had work. So last year, I partnered with Accent Refrigeration, the old company that I was working with, and the District of Oak Bay, and we built a great energy recovery system together. The project has worked really well and has reduced their fossil fuel emissions fairly drastically. But what does this system actually look like? So at Oak Bay, this is a top view from Google Maps. Probably many of you recognize it. And in that, we're taking energy from their arena, not from their curling club, and providing all their dehumidification, all their hot water for their showers and their pools, and then also heating a tennis bubble off the building. The average curling club couldn't produce the same amount of energy, but would be able to have a drastic effect on their curling club. So this is the top view, and what we did is we installed these high temperature heat pumps that incorporated into everything and drastically reduced their fossil fuels. So, but what does that actually look like? So if we step back, the city of Oak Bay very graciously sent me their greenhouse gas emissions tracked over a couple of years. And so the gray line here was their greenhouse gas emissions from 2018. And then the blue lines here was our greenhouse gas emissions for 2019. So we turned our system on halfway through March in 2019. And if you see here, this drastic drop where this is how much, where the gray bar here in April was how much energy they used the year before that. And then the turquoise or blue bar here is the amount of energy that they used this year. And so this trend has continued all the way along to reduce their greenhouse gas emissions by over 50% and their utility or Fortis bills by over $20,000 a year. So it's been a huge success for them, and they've been really happy with this project. And those are the other types of projects that I'm working on with the CRD, Mackenzie, and Juan de Fuca, and actually a couple more in the Vancouver area now as well. So and what I really enjoy is working with government organizations and organizations such as yourself to utilize this. So that gets close to the end of this presentation, but I hope through this you've gained a better understanding of why should you care about refrigerants. And on a high level, it's that they're the single largest contributor to global warming on the planet, contributing 11 to 15% of the global, or cause of global warming around the planet. And then what regulations are coming my way, or your way, I should say. The regulations that are coming your way after the year 2025, you won't be able to purchase or become much more difficult to purchase refrigerants which have a high global warming potential, such as R134A, 507, 404A. And there are solutions that are being offered by like Opteon, for example, by Chemours. They're coming up with great solutions for that. But it's important to ask those questions today to make sure that you're choosing the right refrigerant so you're protected for years to come. And then what are the two types of energy recovery? You can either reduce your electric usage or reduce your greenhouse gas emissions and your fossil fuel emissions. And they're kind of two ways of looking at heat recovery projects, and they're both great options, but it depends on what your goals are as a facility. If you're looking at just saving the most amount of money possible, installing VFDs is a great way of looking at it. If you're looking at, I want to reduce my fossil fuel emissions as a facility, then installing a high temperature heat pump might be a great option. And also looking at a case study looked at that, and I hope that you had a better understanding of how the system worked at Oak Bay. Everything here was pretty high level, and I'm happy to talk about it in more detail, but that gives you a high level. The last thing I want to talk about is I've worked with the city of Mackenzie on another project, which is a maintenance manual. And most of you who have ammonia refrigeration systems have heard there is new maintenance requirements or operating requirements that are coming your way from TSBC. And the city of Mackenzie was great, and they were fantastic to work with. And basically I put together a maintenance manual working with other people at Polar that basically described how the refrigeration system should work, what operation or what work should be performed by the contractor, what work should be performed by the people operating the plant, and then a detailed instruction list, like you can see here, of ammonia temperature control or brine temp operation, how that work is supposed to be done. And the city of Mackenzie was great, and they said I could just offer this to anyone I want. So anyone who's attending this presentation, we will include it as an email out to you, and I'll email you out a Word copy of this document to be able to use for your facilities and incorporate with TSBC with all of their information. If you want help updating it for your facility, you can take that work on, or I would be more than happy to help you do that as well, to design something that's specifically made for your facility, because there's a lot of items in here which will be able to be used for your facility, but also ones that won't work because your systems are just designed slightly differently. So we'll be providing that. So again, I appreciate your patience and holding back your questions. I've seen a couple questions come in through the presentation, and I'm excited to address them. And yeah, thank you for your time. I'd like to open it up for questions now.
Awesome. Thank you so much for that, Ian. Definitely some great information in there, points that people can take back and at least have a starting point of where to start conversation with those, making the decisions with your plants, those that you're hiring to work on them, to do some work. Definitely some great pieces of information there. So far, we have 3 questions that have popped up throughout your presentation. So the first one I'm going to ask you is, when you're speaking about the grants that people can access for some of these projects, is it something that clubs would have to pay out of their pocket and then be reimbursed, or is it more of a joint operation?
Yeah, so that is a great question. So for all of these grants, that is something that they reimburse you for the costs that you incur. So you pay for the project, and then after that, they will approve the project. So they'll guarantee you that they'll pay for that at the end of the project, but they want you to pay for it and then submit them your basically tracking or bills that you work with either your contractor or your consulting firm. And then they'll reimburse you half of those costs about 2 to 3 months after you submit the bills for them. And that's true of the Clean BC grants and the VFD grants through BC Power Smart, that they don't pay for it up front, that they want you to offset the cost. Also, a really important thing to do, that if you say, great, Ian, I like the idea of VFDs, for example, which is the BC Power Smart program. So these VFDs shown on the right-hand side here. If you install the VFD and then apply for the grant, you won't get any money for it. So they want you to leverage the grant to use it. So it's really important to make sure that you work with your contractor or your consultant to make sure that you get approved for those grants prior to doing any work, because they will not pay you if you do the work before you get the grant.
Oh, that's a really great piece of information for anyone to have with working on these projects. Obviously, we want to be able to access as many funds and help along the way as we can. So that's great. Okay, a few more have gone in here. On the energy savings front, I guess the question is, would you see some of these savings immediately, or some of these happening a year or 2 later? I know you touched on this a little bit throughout your presentation, but could you expand a little more if you're able to?
Yeah, so where you see these savings is in your bills from BC Hydro and Fortis. So basically, the second the VFD or the high temperature heat pump starts to operate is the second you stop using as much natural gas or electricity. So you wouldn't see the $1,500 savings for, this is the pumps, for example, VFD on the pumps. You wouldn't see that day one. You would see that accrued over a year, and every month your bill would be a few $100s less, sort of thing, if you incorporate it. And if you incorporated both of these, you would see around, I did a quick calculation here, 6,000. So you would see around $500 less per month spent on electricity, for example, for reducing your electricity usage. And it's the same for a high temperature heat pump. You would see your electrical bill go up a little bit because you're using electricity to power the heat pumps, but you would see an equivalent of around $5,000 savings per year, because your Fortis bill would drop by more than your electric bill would increase. Does that answer the question?
Yeah, I think that answers the question on here. Hopefully I'm interpreting it correctly. We do have a fairly targeted question here. With the new operating, what are the new operating equipment needs for an ammonia system? So you talked about some new requirements. Are there any that you could specifically speak to?
Yeah, so there is a manual that's going out. It's in the preliminary stage right now. I'm working with BC Hydro to actually help write it, to help to write the requirements for that manual. And in that manual, they specify what the new requirements are. So basically, it's what are your evacuation plans? What are your maintenance plan? What work do you have? Agreements with your contractor to take care of your equipment, what work is done by the contractor, what work is done by you. There's a fairly extensive list. And this manual that I'm providing doesn't actually address all those items. Brad Coleman through RFABC actually put together a fairly extensive manual for these systems. And I'm pretty sure he would be willing to share it with you guys as a template because he already sent it to TSBC for review. He sent me a copy of it, but I don't want to forward his manual to everyone without asking him first to help him review it. But the big thing that this manual that I wrote was looking at was saying that the manual that Brad put together was probably a 150-page document. A lot of it was copied and pasted from other places. So by all means, he didn't write it all. He said he spent probably like 3 or 4 days just going through and making this manual and taking other pieces and bits and pieces. But the point of the manual I put together was to actually say like it's a practical manual, because most of the time if you have a 200-page binder, I'm sorry, I'm like you guys. I just put that 200-page binder on the shelf and I never want to see it again because that's a lot of paper to read and understand. So the point of the document that I put together is it's 50 or 60 pages. And what it does is there are checklists that go along with this manual. And so it has a daily checklist, a weekly checklist, both broken down, and then an annual and a semi-annual every 5 years, depending on your equipment. It's broken down for the owner and then also for the contractor. And it lists everything in there. And then for the owner, being you guys who work in curling clubs, it says, okay, I need to do this work every day or check the systems because I'm not risk assessed, or this is what I'm supposed to operate at. And then if I don't know how to perform this work, it actually lists a section in the manual that tells you how to do that. So you're not supposed to look at the manual until you're like, oh shoot, I've never done this before. I don't know the ammonia temperature control, for example. I don't know how that operates. I don't know what I should do or shouldn't do about that. And then you flip to, if you look on the left side of my screen here, 7.5.3.4, it'll tell you that in the little table that you have, and then you can flip to that section and say, okay, let's read about that. So it tries to make it really simple for you. So that's what I was trying to do. So there was kind of 2 problems, and this is one thing I've been talking to TSBC about, is saying we don't want to be over prescriptive of what we're trying to do, because we want to make sure that everyone can operate well, because curling clubs don't have the staff like arenas and don't have the ability to take on all the extra work. So it's trying to build simple systems that actually are useful. And I said for ammonia, and it's true that ammonia is getting looked at quite closely right now, but TSBC has also told me that they're going to start looking at freon plants too, because they're a dangerous chemical as well. And in the industry, there's actually, there has been more injuries due to freon than due to ammonia in the life cycle of refrigeration systems. So they're going to start looking at freons after they've looked at ammonia. And that should start coming in the next couple of years. So that's an important thing to think about too, if you're looking at shifting away from ammonia to a freon system for these reasons. Just something else to think about, that I would have discussions and I would incorporate TSBC to say, to make sure that you have all the facts before you're making a decision.
Yes, thank you for highlighting that. We've heard similar things as well. Curl BC has been lucky. We are at the table with Technical Safety BC with this maintenance manual too, making sure the needs of our curlers and clubs and members are also being met, and some of the challenges that we do face. So they've been great to work with that way, and hopefully we get more of a heads up of changes that are coming down the pipeline. So thank you for that. Okay, a whole bunch of questions have popped up here. Where do we go from that? So let's go to, what is the risk or downside of using a VFD? If none, why were the systems not designed this way from the start?
the only risk or downside of installing a VFD is that the fact that if they fail, sometimes your brine pump will fail, and dirty power, or what we call brownouts, can sometimes hurt VFDs. But you can install them with bypass, which we call bypass, which basically gets rid of that problem. Going back to the other question of why weren't they installed, they weren't installed because they cost more. And so the contractor if you have two contractors bidding on your same job, one contractor could put VFDs on your system, but their number would look higher than the other contractor that's going to build another system. And so even though in the long run it makes sense, a lot of the time they weren't installed in the beginning because they're a technology that's been on the market. They cost a lot of money. They've dropped a lot in around the last 5 years to become much more cost effective. So that's why they're getting installed now. So I bet you if you built a new system now, it would get installed, but they were costly more than about 6 years ago. They were very expensive. And then also on top of that, it's just gonna, when contractors are bidding competitively for jobs, they're trying to remove as much cost as they possibly can. So this is a really simple way to reduce their cost. And so it often ends up being an afterthought if you don't ask for it in the install. And that's why they weren't installed. But they're generally really good options and good solutions to save you a lot of money.
Thank you. Thank you for clarifying that. And it does highlight, ask the questions if you are in a process of bidding, of finding out what those numerical differences are and where they're coming from. Sounds like it's fairly important. Going to your manual a little bit more here, does your manual provide a framework for the costs to do the necessary work? So, in this year, task A would be between this amount of money spent. Does it go into that level?
I didn't detail that. If that was something that someone wanted me to look at, I could look at it for them if they wanted the manual updated. They're pretty normal tasks, so a lot of the time, I bet if you looked at your bills from contractors before, you could pull these things out, or you could talk to your contractor and say, this is the work I want you to complete this year. Can you please give me an estimate of how much it's going to cost for me to do this work? And they could help you with that. And it also depends on the expertise of the people operating your plants. There's certain, you'll notice there's certain jobs that the contractor has, or have identified work for the contractor to do, that the arena owner could do themselves, but McKinsey decided that they would rather have the contractor do that work than the owner do it. And that was for safety reasons and the staff they had on site and just previous experience and really liking the contractor that they work with. So there was lots of good reasons for making that choice, but I haven't broken that down in detail, and that's something that wouldn't be very difficult to do, but it is clearly, the scopes of work are clearly defined, so whoever you work with as a contractor could help you with that pretty easily.
Awesome, thank you. Okay, there's so many more questions on here now. Okay, so let's go talking numbers. If you were to do a renovation from an existing system, are you able to make the change from one refrigerant to another from what you've started with? And do you have any insight as to going down the path of retrofitting something versus putting in a whole new system?
So depends what you have right now. So this is Chemours is a company that I stole this slide from. This just shows some of their refrigerants that they have. So a lot of refrigerants they have developed which they call drop-ins, and they're not true drop-ins, but they're pretty good. And so what it means, so if you had, for example, an R134A system, you should be able to retrofit that plant and put in R513, or if you have an R410A plant, you should be able to retrofit that and put in a different refrigerant. So there will be solutions which will be provided, so that's fine. But the question will be, is the alternative, does it have a low enough global warming potential in the future? And what are the problems caused by shifting from that refrigerant? So the only refrigerants or what we call future proof, that they won't get phased out or won't be regulations met to them, um, they are ammonia, CO2, nitrogen, air, and propane are actually the ones that people use. So propane, CO2, and ammonia are used quite extensively in Europe. CO2 is being used more in North America, and ammonia is used all the time. We all know that refrigerant. Other refrigerants such as R134A, they're great refrigerants. And actually, so the heat pumps that I would design for facilities like yourselves, they wouldn't use ammonia in them. They would use R513, and that's because of a whole bunch of other reasons. But sometimes it can be cost effective today to install, for example, an R134A plant, and then look at shifting tomorrow. So it's not necessarily, there isn't one solution fits all, which is unfortunate, because I'd like to say, look, for curling clubs, here's the solution, here's the piece of paper, this is what you do. But there isn't one solution, because every facility has a different set of constraints, problems, and desires. And so because of that, the options change for them. But you can put a drop in for your refrigerant, and you can shift away. But if you're in something with, like for ammonia, for example, if you're in an ammonia plant already, your probably most cost-effective solution is to stay with that for the future. But that being said, you might have to become risk assessed if you're not risk assessed right now, and have 24-hour operators if you're not risk assessed, and that can be quite expensive. And that's why shifting to something like R134A may be a great solution for you in the end, then, because of the high cost of keeping people around 24 hours a day. So those are all the questions that you have to look at before you make a choice one way or the other.
Thank you for that. Going on the previous question that we answered about looking at what the costs for task A, B, or C, we have a little more clarification. So if a board member making these decisions at a club, I guess they're just asking, how do they even know what is a reasonable cost for this mandatory work? And knowing which things are actually dictated by either the government or, someone like Technical Safety BC or WorkSafe BC. Yeah.
So you were talking about this manual again, right? Basically, you can kind of think of it that you have to be a registered contractor to open a compressor, to change a valve. If you can have ROs drain oils from systems if they're properly trained. This manual actually talks about what you can or can't do depending on your training level. That's one item in this document that outlines that in detail. And if you had more questions about that, I'd be happy to talk to it. But it's also a conversation with your contractor, because if you're in a very remote community, you want to get everything done in maybe one or maybe two visits a year, sort of thing, because it can be quite costly to get the contractor to come out and come visit you. So because of that, what I would do then is looking at saying, are there other facilities in your area that the contractor can visit at the same time to reduce their travel costs, things like that. But there isn't a specific thing in this manual that outlines the cost to perform that work. But like I said, if that's something that someone on a board member wanted to get a better feel for, they could take it to the owner or take it to a contractor that they might work with and say, can you please give me a price to perform the semi-annual maintenance? And is there anything in there you think I can do? And then ask them that question, because they'll be happy to work with you on that, because they're there, like me, they're there to serve you and make your lives easier. So, so if you ask them those questions, I'm sure they'll be happy to help. And if they won't help you, I know all of them, so I can give them a call too.
Yeah, it's great to have a connection with someone that's willing to take a look at this. I would say another, possibility for a board member too is reach out to another club that has had some work done and just find out some of the payments that they've had for different work that's been performed as well as a comparable to give you a range as at least a starting point to most clubs are pretty willing to share their information to help each other out.
That's a great point. Yeah, that's a great point. Thanks for saying that.
Okay, we do have a question about, are there any savings or grants out there for plants that still use oil as a fuel source?
Fuel source. You mean like a boiler?
They didn't
So
specify.
so if you were using, so I'm going to interpret that. Please ask another question if I'm off base. But what we do when we calculate, so what Clean BC does, if you're using oil to produce hot water and things like that in your facility, we take the fuel source and we calculate the amount of CO2 released by burning that fuel source. And so this 56 tons that I've calculated here, that's based off using natural gas. If you're using oil, that number goes up because natural gas is actually one of the cleanest carbon-rich fuels to burn to produce heat or energy. So if you're using oil, you'd actually gain more money from the government than if you produce natural gas. Propane is the same thing. If you're a community that uses propane for a lot of your heating needs, that number will go up and you'll actually be eligible for more money from the government because the amount of CO2 that you're not releasing into the atmosphere every year will be more significant if you're not using natural gas.
Great, thank you for answering that. Okay, so we have a question about, is a power factor correction capacitor worth investigating? Do you know what the payback time is? And they've noted here that their demand changes are 20% out of their electricity bills.
Right. So your demand charge, I actually don't know if that feeds into your power factor. So I'll have to say, I'm sorry, I don't know the answer to that question. I'm more on the mechanical side. So the VFDs are just a simple solution. What you're basically doing is if you have a lot of what we call inductive load in a system, and this is going back to university for me, so I'm sorry if the person who asked the question knows more about this than me. You very well might. But basically what it does is it changes the equivalent power that you're taking from the grid. So I don't know the answer to that question in short. I have friends that do, and if you want to email me, I can put you in contact with them. But I don't know the answer to that question off the top of my head.
Great. Well, we definitely appreciate the honesty on that, and at least getting pointed in the right direction to find someone would be helpful. So hopefully, if there are any other questions, please feel free to forward them to me, and I will get them to Ian to get you in touch with the right people. Okay, so we have, when looking at a new build, what asks should clubs make of the contractors looking for builds? So, you mentioned, they take something off like a VFD, looking at refrigerant type, future sustainability. So what would, if you had a list of maybe the top 10 things people should ask, what would they be? Sure.
So I would say that you should ask them to make sure that they have, first off, that they have reviewed the regulations that are coming from TSBC, because they all have access to these grants. And so there's things like, I would tell the contractors the most important things that are important for you in this build. So is capital cost the most important thing for you? Or have you been able to secure some grants to this that you can pay a little bit more money today to, say, install plate and frame heat exchangers that won't require to be opened after 10 years and looked inside? Because I'm sure a bunch of you have shell and tube chillers that you all heard from TSBC that they wanted to see inside. So there are questions like that. The reason why shell and tube chillers have been installed for the last 20 years is because they are very cost effective. And they are cost less than a plate and frame heat exchanger. But after 10 years of operating them, you have to incur sometimes up to $20,000 in cost to open them up. and take a look at it. So I would tell the contractor, these are the things that I want to see. So I'm very sensitive to, say, cost, or I'd like to look at greenhouse gas reductions, or I want to make sure that I'm utilizing things with really quick payback periods. So like VFDs, give them an example of that. Those are the kind of things I want, those options. And I would just ask them for a bunch of options and make them work for you and say, here's a few different prices that we can provide solutions. A big part of it too is you can hire, unless a large part of it is if you're building a whole plant, it may be useful for you to hire a consultant. There's a few of them. I'm one of them. There's a couple other ones in BC to help you figure out exactly what you want, because that's actually my job day in, day out. I sit down with you, I interview you, I say, okay, what are your desires? What do you want? What are your cost constraints? How can we build a system within those cost constraints? I perform an in-depth interview, and then from there, design a system around those so that when a contractor provides you with a bunch of quotes, you can compare apples to apples. So when Simcoe and Fraser Valley Refrigeration are both bidding on the same job, when they have a document in their hands that tells them what they have to build, then they're bidding on the exact same job, and that document has been curated to allow you to have what you want. And like I said, I'm offering 20% savings too. So in terms of cost effectiveness, now is the best time to get that, for better or for worse. Sorry, I'm not trying to direct work towards myself, but I honestly think that might be the best solution.
Awesome. Well, thank you for that. Definitely some good starting points for people to think about. And I really liked how you pointed out, really making these people work for you rather than feeling like you need to do all the legwork yourself. So there are resources out there to help us through this process.
Yeah. They want the job, so they're there to help you.
Yes. We have just a couple here left, and being conscious of time, we're almost at our hour here. Do you have an opinion on the future of refrigerants and ice arenas in terms of environmental stewardship? Would you see, clubs or arenas eventually becoming really expensive to operate due to different regulations, or are things happening in your field to battle that a little bit?
So, great question. Thank you for asking that. Hard to answer. I wish I could predict the future. I'd be in a different industry if I could. If I could predict the future, then. So the big thing I think is that there's been a lot of regulations that have been pushed, and that was the outcome of, we all know, Fernie that happened, and that's because it's been fairly reactionary, that TSBC. But there's been a big pushback from consultants like myself, from your contractors, and also from you guys to say, look, that we want to install these systems and we want to operate them. We want to provide great services for our communities, but we need to make sure that they're cost effective and that we can do that going forward. So that has been a discussion. So I've seen TSBC put out regulations and then pull them back, and put out regulations and kind of say, okay, like, we did say that a year ago, you're right, but we realize that's a bit onerous. And so that's what I'm seeing, is that TSBC is starting to say, like, we want to work with you to make sure that we're not putting too much requirements on facility operators. And so a big one, for example, was new ammonia refrigeration systems for curling clubs can now be designed to operate below the threshold to require operators. So that's like the R134A systems, or the Freon systems that don't require operators. So you can build systems that are good for the environment and also don't cost an arm and a leg to operate too. And one of the other great things about ammonia is that it's also the most cost-effective refrigerant. It will basically have the smallest operating cost for your facility going forward. So there's pros and cons in everything, because it can cost more to install too. So there's always a payback period, and that's the kind of stuff that I think is really important to look at. But in terms of what's going to happen in the future, I think we've seen a lot of pretty prescriptive regulation, and I think in the coming years we're going to see that pulled back a little bit, because they want to work with us. And I'm sure from Curl BC side, maybe you can speak about that. How have those conversations gone on your side?
so far they've been very positive, as you said, looking to work with those that are going to be impacted by the decisions on their end of things, and really having a better understanding of the position a lot of our members are in, and being cognizant of, you know, finding other resources or funding opportunities in order for compliance to be reached. So the discussions are there. Obviously, you know, not at a point with solutions yet, but it is great to see, since Fernie, a little more partnerships going on and people working together. So to keep everybody safe. Yeah, and I thank you for answering that very tough question. Like you said, it's really going to depend on what your club's priorities are, where you are, and the resources around you as well. You know, it could be a difference with an area having access to a lot of contractors and operators versus somewhere where more remote, where your options might be limited. So those are things that will you'll have to take into consideration. And luckily we have people like Ian who can help with those and finding the best solution for our club. So are there any last minute questions from anyone who's still left on here before we say goodbye? I'm sure if you come up with something afterwards, feel free to send either one of us an email, and we'll find you the answers the best that we can. But Ian, thank you so much for being here with us tonight, and you know, giving us more information, starting a great conversation, and giving some insight into the industry here. So really appreciate you being here with us this evening.
Thanks so much for having me. It's always fun working with people. I always love meeting new people in the industry, because I find that everyone in the industry is trying to do the right thing and trying to find the best solution to get there. So it's a great industry to work in, and it's a privilege. And so thank you so much for coming, and I looking forward to talking to more of you in the future. Another question.
Oh. Thank you, Ian. Lots of great information tonight.
Yeah.
Well, on that note, stay safe and healthy, everyone, and hopefully we'll be in touch with some of you following this, and please keep the conversation going. And if there's anything else that you need help with around your clubs during this time, please do not hesitate to reach out to us at Curl BC, and we are here for you. So thank you, everyone.
Great. Thanks. Have a good night.
Good night.